For the first time in history, a spacecraft has dared to enter the sun's atmosphere. This feat of Parker's solar probe will always be remembered in history because neither any metal nor the world's harsh Earth can bear such heat. Then the question arises that why does Parker's solar probe not melt in such heat? How is it working perfectly even in temperatures of not thousands but millions of degrees? Kushambi Nazreen once again in MTV's videos. In the beginning of 1900, scientists noticed a strange phenomenon during research on the sun. They were estimating the sun's heat from the wavelength and color of the light emanating from the sun. This was being done from the ground with the help of a spectrograph. Let us tell you here that there is a direct connection between the color of the light and its wavelength and its temperature. The result that came before the science departments created such a mystery that could not be understood till date. What they saw was that the temperature of the surface of the sun is 5,500 degrees Celsius, whereas the temperature of its outermost atmospheric layer, corona, is more than 5 lakh degrees Celsius, that is, at least 100 times more than the surface of the sun. This is like the heat we feel when we move away from the fire. This is a very unique phenomenon, which scientists have been trying to understand for the last 100 years. Normally this layer is hidden in the sunlight, and it is possible to see it only during solar eclipse or with the help of chronograph sunset. After the establishment of NASA in 1958, many space missions were started. One after the other, satellites and spacecrafts made their first observations. We stepped into space, but, to understand this unique phenomenon of the sun, it was necessary to make a probe that can go into the corona wave of the sun and take stock of it and see what is going on there. That probe can study the rays coming out of the sun, even at 5 lakh degrees Celsius. But obviously this was not that easy because honestly it is so hot that it is very difficult to even guess it. The melting temperature of iron is 1500 degrees, whereas the world's hardest metal is tungsten, and its melting temperature is also 3422 degrees Celsius. That is, the surface of the sun will melt both these metals in the blink of an eye, so imagine what will happen to them in the corona layer where millions of degrees are heated. There was an even bigger issue than this. Yes, it is very difficult to go close to the sun, which has bound the planets of our solar system together. First of all, understand that if a satellite is placed in the orbit of the Earth, if a spacecraft is to be taken out of Mars and brought back to Earth, its speed has to be reduced so that the gravity of the Earth can dominate it and attract it towards itself. Similarly, if it is to be sent to some other planet and not to Earth, its speed is increased so that it can get out of Earth's orbit. Suppose if a spacecraft is to be sent to Mars, it is first brought into Earth's orbit with the help of a rocket, and then it is taken out of Earth's orbit at the right time, right angle and right speed. Taking a spacecraft out of Earth's orbit is actually much less energy consuming. It reached Earth's orbit with the help of a rocket, but now, well, there are no rockets here. Instead, small rockets fitted in the spacecraft itself are used. Mars is taken out of its orbit because it's much closer to the sun than the Earth. So the angle at which the spacecraft was launched isn't quite that much. But, the distance between the sun and the Earth is 150 million kilometers. And to take it out of Earth's orbit and put it in the sun's orbit, the angle required is really big, and obviously the energy needed is also huge. A rocket with so much energy and power just hasn't been built till date. So, NASA experts decided that before sending the Parker probe to the sun, it will actually be sent to Venus first. Venus is the second planet in our solar system, and its gravity can be used to increase the speed of the Parker probe. But there was a problem here. The problem was that Venus is a small planet, and, due to this, its gravity is also less. To reach the record speed for the prop to go close to the sun, it was necessary for it to revolve around Venus 24 times. Only then it could reach the sun. It will be able to reach the closest point on 12th August 2018. The Parker solar prop was launched from Kinnamaril Air Force Station. For this mission, NASA has planned a time period of 8 years. To reach the closest point of the sun, Venus will be used 24 times. In every orbit, there are 37 hours in which one gets a chance to do research on the sun. That is, in total 8 years. This propeller will be able to do 900 hours of research on the sun. On the 28th of April, 2021, NASA confirmed that the Parker probe had, successfully entered the sun's corona during its orbit. This was a huge milestone in our journey to understand our closest star. The corona, or you could say corona, is mysteriously about 100 times hotter than the sun's surface. Yeah, that's actually true, and the probe managed to verify it after entering. But why is that the case? What exactly is the force that's making the corona layer so much hotter than the sun's surface? Well, research is still ongoing to figure this out. So now let's talk about a big question. Why isn't the solar probe just melting, especially after all the investment that went into it? The side of the Parker probe that's facing the sun has a special heat shield made from carbon foam. But it's not just any foam. Ultramat company specially designed this material to absorb the sun's intense heat. Interestingly, this foam is 97% empty inside, which actually makes the heat shield way more effective. On top of that, there's a layer of carbon-carbon composite made by mixing graphite and resin applied to it. This mixture was put on both sides of the heat shield and then superheated, turning it into the purest form of carbon because, as we know, carbon is an excellent conductor of heat. And finally, the side of the heat shield that faces the sun is coated with a white serum, so that most of the sunlight gets reflected and doesn't enter inside. Apart from the heat shield, the remaining part of the Parker solar probe is designed in such a way that it will always be in the shadow of this shield. But even after all these things, Parker Pro can bear a maximum of 2,500 degrees Celsius of heat, whereas the temperature of corona is 5 Locke degrees Celsius. Now it is quite easy to understand how it is bearing so much heat. According to the law of thermodynamics, heat also needs a medium to be transferred, as in summer, the particles present in the air on Earth carry the heat back inside them, due to which it feels hot even at night. If there are less particles, then the heat will also not be able to travel so easily, as putting your hand in boiling water will cause immediate burning, whereas if you put your hand in a 300-degree oven and take it out immediately, we may not even know about it. This is possible because water molecules touch us, whereas nothing touches us in the water. Experts say that the heat shield of Parker solar probe is 1,200 degrees Celsius, whereas its backside, where sunlight does not reach, the temperature is in minus because there are no particles there which can transfer the heat. This is the reason why Parker solar probe is not melting, despite being so close to the sun. Hope you all will like and share this video. Thank you very much for your loving comments. See you in the next amazing video.